Hello, my name is Dr. Preethi Vela Anandam. I am working as an assistant professor, the Department of EEE in SNS College of Engineering. Today, we are going to see about a case study of buck converter. So, what is buck converter? It is a DC to DC converter and is used in various applications such as smartphones, laptops, etc. So, this case study examines the design and optimization of buck converter for a portable device to achieve the higher efficiency and the longer battery life. Let's see the problem statement of this. The problem statement is that a leading electronic manufacturer aims to design a buck converter for their new smartphone model. The converter's primary objective is to step down the battery voltage to provide a stable power for the device's core components, including the microprocessor, display, and the various sensors. The design must meet the following requirements. Let's see the requirements one by one. The input voltage should be of 3.7 volt, a lithium ion battery voltage, and the output voltage Vout should be of 1.2 volt, and the output current should be of up to 2 amps, and efficiency should be greater than 90%, and there should be a small form factor to fit within the device's limited space, and should have a minimized heat generation. These are the design requirements of a buck converter for a portable device. Let's see the implementation, how we are going to implement it. Before that, we should know the buck converter design. Let's see the selection of the components. Inductor L. The inductor L is selected to ensure a suitable current ripple. It should be designed to handle the required output current without saturating and should have a low resistance to minimize the power losses. And next one is the MOSFET selection. The MOSFET switch should have a low on-state resistance and fast switching capabilities to minimize the conduction losses and the switching losses. The next one is selection of a diode. The diode should have a low forward voltage drop to reduce the conduction losses. The next one, a selection of a capacitor. The output capacitor should have a low equivalent series resistance to provide the stable voltage and to minimize the output voltage ripple. And the control circuit. The control circuit, nothing but a feedback control loop using a microcontroller or a dedicated buck converter control IC is very important for regulating the output voltage. And these are the buck converter design. The inductor, MOSFET, diode selection, capacitor selection and the control circuit, everything is given for you. And now we have to move on to the simulation and analysis. Use the simulation software like LT-Spice to model and optimize the buck converter circuit. Analyze the transient response, voltage ripple and the frequency, efficiency, and adjust the component values and the control parameters to meet the design requirements. And now we are focusing on the prototype and testing. So prototype testing in the sense, fabricate a prototype of the buck converter circuit, measure your output voltage, current and efficiency under the various load conditions. And then we have to make a necessary adjustment based upon the real world performance. So we need to measure the output voltage, current and efficiency under the various load conditions in the case of your prototype testing. And efficiency enhancement, thermal management and the EMI compliance, everything is very important for designing a buck converter circuit in the case of your portable device. And let's see the conclusion part of this. The conclusion is that the successful design and optimization of a buck converter for a portable device have enabled the manufacturer to meet the stringent power requirements while maximizing the efficiency and minimizing the heat generation. The efficient power regulation provided by the buck converter contributes to the longer battery life and improved the device performance, making it as a critical component in the modern portable electronics. And then let's see the assessment part of this. Let's see what are the merits and drawbacks of using the buck converters in industries, and what are the other industrial applications of buck converter. You please do this assessment question, my dear students. I have referred the references like Alok Jain, Power Electronics and its applications, Mohammad H. Rashid, Power Electronics Circuits, Devices and Applications, K.R. Verma, K. John, Chiku Abraham, Power Electronic Design, Testing and Simulation books for the reference. So thank you for watching this. Thank you.